All right, so we have two more graphs we have to go over. They're pretty simple, and if you understand bar graphs, they won't be that hard. The first one we're going to talk about is pictographs. So pictographs, as it says, picto, right, is basically pictures in graphs. So in this example we have cars counted at some intersection, whatever, on different days, so we can see there. Then we got to use our legend that's on the side. The legend's going to tell you what each picture represents. So in this case, one car represents 5 cars. So the way we do it is we count for Monday, okay, there was 4 cars, and we multiply that by what each car represented. So 4 times 5, that means there was 20 cars. For this one, there were 8 cars, so 8 times 5, 40 cars. 6 times 5, 30 cars. And this was 25, 5 times 5. Okay. Basically, they're just like a bar graph. They show different sizes. Usually they're horizontal like this, we're saying. They show different amounts. It's usually pictograph looks a little nicer because instead of just having bars, you have pictures of cars. You can see it's about cars because it's a picture of a car. They're usually used in stuff like infographics to make it look nicer, but they are inaccurate. Bar graphs are good because you have all those lines. It's very easy to see exactly how many there are. But as we're going to see in this question, when you have fractions, it's a little hard. The other thing that's nice about them is when you have a huge number, it's easier to show than having like a ginormous scale. You just have like, if your legend was something like it represents like 10,000 cars, then you only have to draw, like 4 little cars represents 40,000 cars. Oh, okay, that's easy to see. It's an option. The other thing we need to know, just say on Friday there was, let's go back to the original scale, 5. Let's say on Friday there was 15 cars, and we need to know how many little pictures of cars you need to draw. We would do 15 divided by 5, our legend, gives us 3 cars. So I would draw 3 little cars. That's my sweet drawing of a car. Let's look at this example. The only new thing it throws in is you can have like half, quarter, whatever. So in this case, each of these pumpkins would be 50 pumpkins. So this would be 2.5 pumpkins times 50 gives you the total, which could be 125. Okay? If it's easier to think like 50 plus 25, that's cool too. That gives you the right answer. And as we can see, looking at this really easy, it's Edwin who has the most, Jacob has the least, Danny and Alex are tied, second most. That's the idea. You need to be able to see who has the most, who has the least, and start to ask questions why. Histograms, let's write this at the top. They're a special type of bar graph. The only difference is that we are, instead of looking at things broken up into categories, so when we did bar graphs, we might do like people, so we might say like favorite color. So you say like red, blue, right? And you say how many there are. You might also say something like, what was your mark? If you ask someone, what was your mark, you're going to have to do a different bar for every single number. You do like 1%, 2%, 3%, 4%. You're going to have all these stupid little bars, and a lot of people won't get 1, 2, 3, 4%. They're going to get something like, 80, 81, 82, and you get all these different bars, right? So what a histogram does is it groups them together into groups that make sense. The side is still the amount of people, the frequency, how many people got it, but then you put it into clumps. So maybe for marks, you do, okay, who failed? And you put a bar. And then who got between 51 to 60%? And then you do 61 to 70%. That kind of idea. So by breaking it into these chunks or classes or intervals, wherever you want to call it, it's easier to make it into a bar graph for certain situations when you're working with numbers. And in histograms, the bottom's always going to be numbers. So if we read this one on the side, it's labeled a little different. We have the labels on these lines in between. So the idea is that bar in between represents all the numbers in between 50 cents and $1. So it's the numbers in between. Same with here, this one would be between $1 and $1.50. So if someone had like 125, they would be part of this one. If someone had 99 cents, they would be part of this first one. Okay? So reading a histogram is just like reading a bar graph. If you want to say like which one is the most, you say, oh look, this one's the tallest, right? It goes up to here. There were 7 people who were in between $1 and $1.50, or 7 items on the menu that were in between $1 and $1.50. Whereas over here, there were none that were in between $2.50 and $3. The other thing that you can do that's kind of interesting is to try and think about like the average. So normally to find average, you'd have to take all the numbers like 8, 9, 4, 7. You'd add them all up and then divide by the number of terms that they have. And then divide by 4. Okay? In a histogram like this, it's a little bit easier to see an average because you can kind of see where the bar is. So looking at this is obviously the most popular, but we can kind of think, okay, well here we had 4 cards on this side, and then on this side we had, what is that? 3, 3, 2, and 1, and this was 7. So even though that's the most popular, the average looks like it's going to skew a little bit this way, because on this side there's only 4, on this side there's 9. So the average is probably somewhere around here in this area. It's easier to see the average in a histogram like this than if we just had all the numbers listed out. That's one of the positives of a histogram. This is another example. So looking at this, you can tell where most people are. Looking at the graph, it's pretty clear that this is the biggest, but this one's like basically almost as big. So I'd say that that is where most people are. There's about an equal amount on either side outside. So I would say the average is going to be right in here, probably closer to this side in that range. Now the thing with the average is I don't know the exact average because it's a range. So these people, see how it says 8 people? That could be 8 people of 160. Whereas this range, it says it's 7 people. That could be 7 people of 159. Even though those are really close, they ended up being in different bars. So that's one of the downsides of histograms, is that they're a little bit inaccurate. And that's basically it, how to read these 2 types of graphs.